Hi everyone, welcome to the second session of the drainage design. So in this video, we're going to see how we can calculate the pre-development calculations, storage estimates. So basically there are two main things. One is called hydrology. So the like precipitation, catchments, runoff is called hydrology, and the flow of water through the pipes, ditches is called hydraulics. So I have some notes here for you. If you like, you can take the screenshot of this one. So hydrology is basically how the water system into the work. We have precipitation and then the runoff, it goes to the catchments and hydrographs. This is basically called the hydrology. So infiltration losses, pre-runoff, and then we have the hydraulics, like from the water it goes through the pipe networks, it goes through the ditches, it goes through the culverts. So this is called the hydraulics. So in pipe channels, water levels, the velocities, so basically hydrology and the hydraulics. And we will start from our hydrology, that is the pre-development calculations, like what are the rainfalls in the event, and we can use using the UK search website. So UK search, and we can just start doing this. So for the pre-development calculations, I will go to the website known as UK search. You will have to create the account on this one. I already have my account set up, and you will come at this one. You can also calculate this directly into the InfoDrainage. We will see that later, but this is more preferable by the LLFAs and the other environmental agencies. So you can just put some of the anything. You can put any job reference. You can say like any references if you have. So site as we can say the site location. So we have to find our site location in order to put here. So we will have to go to the maps. I do have the site location. I will copy the postcode. We will just need the postcode here. So it comes to the, yeah, it's correct. We can't change the easting and northing, so it's the nearest that we got here. Yeah, so it's correct now, and we have to measure the site area that we can do from our site design. So I use the command AA and turn on the maybe snap mode. So this will we can just on the safer side, we can calculate from a bit outside the site. So we click through all the corners that we have our site area. This will be calculated for the greenfield runoff, like if we don't have any of the constructions, and if it's a totally green site, like only grass or anything, not any developed area. So we have to make sure that way the runoff from the site isn't more than that. So it's just this way we can just click, and after last click we can press enter. We can see that the area is here, so we can just copy this area. So the area is this, and we can just paste it in our notes as well. Maybe we will need for the site. Just area or area site area. So this is the site area. So we'll change it to hectares, 2.09. Also we can 2.09 hectares. Now we will put this area into the site. So green feed runoff, select the method. The latest method we will use FEH 2025. Now we need to download the FEH data that we will need from the FEH website. So I will go to the F site, and now you can, if you once you will log in into the web service of the FEH, you will be able to see the sites, and you can either put your postcode, your coordinates to locate your site, and after you locate, then you will have this. For example, your site is here, you will just right click and do the this for the catchment boundary. So you will be able to see if you have a very big site, like you need to download the catchment area, but we don't need this catchment area, we just need the point data. For example, you will come here, click here, it comes with the point data. So you need to have the credits, and once you will have the credits, you will be able to buy this data. So I already have downloaded this one, the point data that is for our project, and we can also take the screenshot and make the notes into this one here. So this will also be helpful, and then we will have to populate this data here. So what we can do is this one. I have this data, and I will click open this one. I will go to this green runoff rate. So I have downloaded the power tools. I don't know if you guys know, this is very nice. So power tools is basically power tools, power 12, but this will just stick this one. So I will use control my shift and T. This will keep this on this one. I don't have to worry about that it goes to the back screen. So we need to put star 9120. So 9120 is 758, and we have to enter the first 19. See this one, then that is 0.682. Then so everything else is populated automatically. The map value is 7, the 7. Yeah, so this one comes with the Q bar is 3.7 liters per second of our site, and return period you can say is 1 in 2, 3.3, and then we have 6, 8.6, 11. So everything we have now populated. So now we can just download this one, because we will need to use those values for our site. So we can save it as a PDF. We will just close this one, go to our site that was working. So now that we have, now what we have done, we have already calculated our pre-development, we have downloaded the FEH data. Now we can use our, so these are the values that we have to keep in mind before designing our work, that the runoff from our existing site is 3.7 liters per second, and after development this we should be either 3.7 liters per second or below the 3.7 liters per second, but this one for 1 in 100 year program. So this makes sense. So again, 3.7 liter per second is the maximum that we can do for 1 in 100 plus the climate change level. So these are the regulation we have to be limited at. Now we can do is open our InfoDrainage. So once we will open the InfoDrainage, we again have the at the top we have this field. You can see the rainfall manager. So we will set up our setting for the rainfall manager and the design storms FEH, and we will load the FEH file that. So you can actually, I have already installed, so you will go to this one, you just click export, it will automatically download that file. So once you will download it, you can just locate here 2022 FEH 2022. Then we need summer and winter events. The return periods, basically we will need 1 in 2 years, 30 plus climate change, for example 40% climate change, 100. So this means like a storm event that has the probability of 1 in 100 years. So for example 1 in 100 means every the storm probability is 1% a year, or you can say once in every 100 years. So but the climate change allows is to increase the storm intensity of the rainfall events, and 1 in 30 similarly means that storm occurrence of that will be after every 30 year, once after every 30 year, and 1 in 2 is like storm, the peak storm will occur after every 2 years. So this is why we are doing these storm events, and then we will put the climate change. And now storm durations, so we have these durations that the storm will be simulated in the InfoDrainage by which storms. You can select all, or you can just select default. And then now we have set up our rainfall data, that is basically the hydrology of our site, and I will click OK. So as I mentioned about how we can calculate the pre-runoff details in InfoDrainage directly, so we can also try that. So prelim sizing, UK runoff, maybe this one, and I will site location 2022 area was we used the area 2.09, and the SAR is 688. That's automatic, and the SPR host. We don't have the host here. You are, I don't know what are these things. So I don't know what are these values, but obviously if I need to put your urban, I don't have here, or we can just collect by this method. This is also one of these methods. That is again 2.09. SAR is we will map the site location, but something, I think the region we have was 7. If we open our drawing, yes, hydrological region 7. So the region is 7, 758. They don't have the soil. Yeah, so I usually use this one, but I think you will put something, and then urban is 0, return period is 3, and then you calculate, it will calculate the values but I use that method. That's more accurate, more better. So you can see it is, we have 3.7 liters, it's 11.7. You can go here and then select your region where the site is, and then you do this one, so it calculates the volumes. So I use that method. That UK search is also free to calculate the runoff volumes. Now what we can do is, now we have done our calculate this one. We can also calculate the stage storage of our site that we need. User input area of our site was 2.09, 907. Discharge rate, the discharge rate we already have is 3 point, that we need the Q bar value. Q bar value is 3.37, 3.7. So I will also add that here. Q bar 3.7 liters per second, and I will put this one 3.7 liters per second. Infiltration at the moment 0. Calculate quick stormwater duration that we have calculated. So yeah, so now it has given us the estimated values. So we have these estimated values that we may need later. So it needs that we need to store the storm of like 1751 meter cube to 1969. So it is just a rough estimate that we need our storage volume for this one. So it can give us a rough guess. Like for example, we can design for example, we can say that we can design some pond of if we go for 1751. Then we can go for example, for 1500 square meter. So 1500 square meter with 1.5 meter depth. So this will give us roughly 1.5. So it will obviously it will give us more than that. So we can even go to 1300 1.5. So it's, so again we can go for example 1000. So it will be fine. So like 1100 square meter, the area of the pond can be the, so this one pond can be of 1100 square meter. So we can let's calculate it, that this is the area that we will need the pond. This is architecture plans, but they don't have did the calculation, they just give the site the location. So we can just measure a rough area of the site. So let's say if I go roughly, so this area we only had 463, and we will need something 1000. So maybe we can design some permeable pavement, something else, but that's not to worry about. So let's start bringing the data into our InfoDrainage file. And what we're going to do is maybe we can bring the whole CAD file, although it just need the surface and this one. So we can just bring the Xref file. So we will go to the CAD import data and we will import the Xref that we created. It crashed our InfoDrainage, so which was, I think, quite big file to handle. So we can open our Xref. We don't need the other side, so we can just copy this area. So we can do select, and then WP is for the window, and we can just do like select the items within the boundary that we only need for the drainage design. So select objects, enter. I will just clipboard copy and we will just paste it to original coordinates, and this is what we need for our InfoDrainage file. So I can do is I can also create a new layer, create it. So layer, we will all put everything on the one layer and rename this one to Xref InfoDrainage, and we will change it to gray. Everything will goes to gray, and change all of this to layer set. Everything will go to InfoDrainage. Color will be by layer, and the layer so this is a block reference. What I can do is I will just break, so quick select and go to the entire drawing. We need to select block, and that equals select all. Click OK, it will select all. I will explode, and something is on the switch on all the lights. So first of all, remove the hatches. So quick select entire drawing. I want to select all, select all, delete the hatches. Now I want again quick select if they have other hatches. No more hatches. Do we have blocks? Yeah, blocks. Select all, and we will explode the blocks. Q select hatch, select all. We will delete the hatch, and then again quick select. I will just do it again until I find no hatch and find no blocks. So it's, you can see there isn't any blocks or any hatches, so it means everything has been removed, or we don't have these ones. Now I will select all of these and change the layer to Xref, and color will be by layer. Now it's been changed, so block Z block will be the grade. Now we can use this file for our InfoDrainage. So only Xref InfoDrainage, and I will just close this one. Now we'll go into InfoDrainage. We will have new design, and again we have to do again because we did a big mistake that we didn't save our drawing. So I will just go somewhere winter 1 in 2 years, 1 in 30, 1 in 30, 40% climate, 100 years, 145, and then we go for the default. Select all and default. Click OK. This time I'm going to save this one. So now we have saved this one, and now we can do is import our CAD import data, the CAD that we have here. This time it works. So deselect all, only one layer. That's why we created only one layer. It doesn't come with a font. So Xref InfoDrainage. So which layer is the font? SP line. Okay, so these are the SP line. So SP lines usually doesn't import into the InfoDrainage. So first we can edit this and change it to polyline. So we can do SP line edit. So SP line edit, and it asks me to convert to polyline. You will be able to see, and specify precision. I will just go, I don't want very precise. Oh well, this is it. SP line edit, exit, SP line edit, select the SP line, convert to polyline. Maybe 10 will be fine. Yes. Now it has created polyline with a lot of vertices. Similarly, we will edit this one to SP line, convert to polyline 5, maybe better. Yeah. And now we do have polylines. And yeah, we can just remove this one, save, and we can remove and re-import. And this one will be Xref InfoDrainage. And again goes deselect all, only one layer. That's this one. Now we have pond location, we know a bit of route, and then quickly save this drawing. Control S for the save from here. Also, we may need to load our surface. So for the surface, I can go outside the drawing, and we created yesterday the existing surface, and export to line XML. Big drawing surface. I will select, export, click OK, and then we will just go to location, and then everything accessible line XML. Close this one, and then import our surface and XML. Existing surface. Do we want to train? No, it's okay. Yes, we can select, you can see this one. Now that our surface has been loaded, don't worry about this one. Sometimes it's obviously doesn't comes like this, but it is a place here, so it's fine. Or we can also try again without re-triangulating. Yes, lower surface and examine existing. If we do not, yeah, still the same. So don't worry very much. So we already have, so we will have some of the main holes here. So this is for the cover level. And I will just turn off. So I just don't want the visualization. So we will just save this drawing. So yes, this is, I think, enough work for today. I hope you guys would practice on this one. or obviously not these files, it's my file, but you go along and then it's better to do practice as long as you go, and from this we will be able. So now these are the notes. We have some of the rough notes here. So we have already calculated our pre-development calculations. That was a Q bar value, and we already have the stage storage estimate, that is this one, and we have FEH data, that is this one, and we have already saved our InfoDrainage file. So hope you guys understand for today's video, and if you guys have any questions, please let me know into the comments. Next video we will see the prelim design of the pipe networks, and then our site, and we will also see through the topographic survey, that where we can have our outfall, or how we can manage our runoff throughout the site, what surds we can use. So yeah, if you guys have any questions, please ask in the comments and I will be able to help. And yeah, so I will see you in the next video. Bye.